on this computer. Okay, welcome everyone who has managed to join this call. So I'm sharing my screen. You can see, I want us to go through these slides very fast. Then I'll leave you to do the assignment at the bottom of the slides. It has some interesting assignments that you can challenge yourself with. So today I want us to talk about the numerical data. Much as we're doing OOP, there are certain building blocks. Building blocks are more like things you need to know before you get started with something. Things that you must know. I'll reflect back on what we did with people did as is it C programming, right? The scientists that did C programming. We went through the fundamentals and we went through some of the building blocks, things that you need to know before you start thinking of calling yourself a programmer. So also here, you know, pretty much as OOP is an advanced programming paradigm, but we also need to know some of the backbones, some of the fundamentals, things that you need to know before you jump on, you know, coding these classes, generating these objects. I remember I left something for you guys to work on to generate a class, and I got feedback from Mr. Cassos that you did that, and I think you did something practical, and your classes were running, everything was working. I'm yet to find out, but maybe I'll put a link up there to see what you guys worked on. Would you all guys have achieved that? Did you all guys leave that session when your classes were working? You did some demos with him? Because it's coming back next week and we'll visit you guys to see the progress. It obviously left you guys with something called method overloading. Can someone confirm that that is what was left behind with you guys to deal with? Yes? Oh, none of you guys attended that session. Okay, Kiza said yes. Okay, so I know all of us, we did fundamentals of programming. People are doing IT, did principles of programming. People doing computer science, did structured programming. So we have the basics, the fundamentals, or things that we need to know before we think about programming. Now in OOP, we also need to know how do we deal with numerical data when it comes to OOP programming. Numerical, the moment I talk about numerical, what comes in our minds are numbers. These are numbers. How do we deal with numbers, right, in OOP? So Java has a different way, though everything is similar. When we look at the numerical data, we are going to look at the different data types, like for instance, integers, float, double, assign, int, long, short, float, double, so many things. So the question is, how do we deal with them? How do we manipulate data of that kind of type in OOP? In C and C++, I know we did so many things. So here, some of the things that you should be able to do, you should be able to, at the end of this discussion, you should be able to know how to select the appropriate types of numerical data. If you're dealing with the integers, because we're going to write objects or classes that are going to give us objects which are going to be manipulating numerical data, string data, so many things. So we need to be able to know which data type should we use here, which one should we use here, assuming I have a class, that a class is going to have the student record, whereby also we are tracking the age. So we need to know the right type we're supposed to use to capture the age data, because age is numerical. Then we also need to, again, also, you should be able to write arithmetical expressions. This one goes without say, the likes of add, subtraction, multiplication, division. At the end of this discussion, you should be able to know how can you achieve this in OOP, right? Assuming you have an object that requires a bit of computations. So how do you deal with it, right? Then also we should be able to understand how to evaluate arithmetic expressions using the precedence rules. So precedence rules, I believe people who did mathematics, they know this. When we look at arithmetic operations, I think when I go back to math, we all did board mass. True or false? Did we all do board mass? Yes, please confirm, unmute and confirm. Did you all do board mass?
Yes.
So we understand that if you have an expression of adding, let's say 2 plus 4 times 6, the calculator will have to apply board mass. Even if you're doing it practical on a paper, you need to apply the concept of board mass. Which one comes first? So this is when the precedence rules comes in. So even the computer, when it's doing these arithmetical expressions, it will also look at which operator has the highest rank or the highest precedence, the one that has the highest priority. So it means it will first consider whatever is there, then it will look for the other things that have low precedence or low priority. Then you also have, you should be able to describe how memory works for objects and primitive data types. In this discussion, we understand that all numerical data is, most of them are primitive data values. Primitive, it means they already come preloaded with the language or the tool, whatsoever you're going to use. So the language already knows them. If you're dealing with a float, it is no, it's a float. If you're dealing with an integer, it knows. Primitive, it means it's part of the language. It knows it. Objects are things that we're going to create for ourselves. The language might not be familiar with them, but we're going to fine tune them to make them understandable within the language. Then we should also be able to use some libraries like the math class, which can give us some provision of doing that complex mathematics. For instance, you want to do square root, you want to do whatever computation you need to do. We have a math class that has all those methods that you can make use of, right? Then also you should be able to generate pseudo random numbers. As we go through this, you'll see some of these things. I would emphasize you guys to go back to these slides and try to do some demonstrations in the codes that are part of these slides. Okay? And Kwagala, how are you? Even you're late.
I'm fine, sir.
You are late. Where is Joaquin?
Is he?
Sorry?
He's going to connect.
Okay. So you should also be able to use the Georgian calendar class in manipulating date information such as year, month, and so this slide has so many things that it's covering, but all these concepts are very, very critical for you to write OP-oriented solutions that cover most of all that will deal with whatever data type, whatever input you're going to submit to this program. Also, you should be able to know how to use the decimal format classes. I think all of us we know in our basic mathematics, a float, the number that has those places of decimal, let's say 3.5.00, 3.5000000. In our finance or accounting or mathematics, I think we always say round off the nearest something. All right, so also here, we are going to use the decimal format class to help us to strip off the preceding zeros, the remaining numbers, and only say we are setting a format. If I'm dealing with a float, you should only have 3 places of decimal. So there is a class already supported with Java that deals with this. You're not going to write things from scratch. If you're going to do the calendars, you need to know the independence, the what etc. You're going to use the class called the Georgian calendar class. Everything is there. You just need to know how do I import this class and how do I access the methods under this class to achieve whatever I want. When we look at the objects we're going to write, it's going to be a combination of so many things. The object can be, we can use the object to do maybe a computation of a certain sales order, so many things. So that's why we need to know most of these things. If you have a problem, you need to set up your program. It's going to be doing computation of a supermarket. Do you know how to do the data types? Do you know how to format the decimals? Do you know how to record the dates? That's why we have all these basics here with us. Then also you should be able to to know how to use the input-output of numerical data using the system in and system out. When I refer to our recent discussions, guys that did structured programming, so programming, we already know this. System in means reading things from the keyboard into the computer. Then system out means printing out or displaying. Okay. So also in Java, it has the same way. System in for reading in. I think for probably C principle of programming, they did C in with some greater than symbols pointing the other side. System out, they use the C out with the greater than symbols looking the other side. I hope I'm making sense to people who did principles of programming. People did structured programming. System in, we use scan D, scan F, scan what whatsoever. If you're reading an integer, use scan F, scan D, scan percentage D whatsoever. Then for system out, we use print F. Are we on the same page? Is that what you guys covered? Yeah, I'm very audible, but when people are muting, I don't even hear any word.
So we're on the same page.
Okay. Now, in Java, as I said, we can add to numbers, we can add the other basic operations, the numeric ones. We can add numbers. However, for us to add numbers in Java or in the programming languages, we need almost like two things. We need the operator, and then we need the operands. Among the x plus y, which are the operators, which is the operator, or which are the operators, and which is the operand? Can someone tell me? X is what and plus is what? XY is what and plus is what? Yes?
Plus is the operator.
Yes. Then X and Y, these are the operands. But before we use them, we need to first declare them. We need to first declare them within the program so the computer creates those variables, and then we specify the data type, and then they allocate storage for us. We did this in programming, all the fundamentals. All of you guys did this. So here, we are going to say, instead of saying x plus y, because if you say x plus y without declaring it first as of what data type, the compiler or the computer will play. You will say, I cannot recognize x. I cannot recognize y. So how do we do it? We say int x, comma, y, or we say int x, terminate int y. Meaning, x is a variable, but of integer type. So it means whatever value you're going to put on x is going to be of an integer. So before we use any variable in our programs, in our objects, we need to first declare them. Declaring them, it means you're telling the compiler that go into the memory, allocate for me space, name it this, so that it's waiting for a value. So if I sit down and say x is equal to 2, the compiler will get the 2, go in the memory, look for where x is, then put a value to there. Are we on the same page? Do I have questions here? Please.
Yes.
Okay.
Yeah, together.
Okay. So the same thing I've talked about. When the declaration is made, memory space is allocated to store the values of x and y. So x and y are variables, but remember we have rules of naming variables. You did that in C and you did that in C++. Right? It shouldn't start with a number. It shouldn't be like this. Shouldn't use a keyword. You remember those things. So here, a variable has 3 properties. It has memory location to store a value. The moment you say int x, terminate, you tell the compiler, go in your memory, create for me space, you call it x, but it's going to store a value of an integer size, right? So it has the memory location to store the value. It has the type of data to be stored, which is an integer, and also the name used to refer to the memory location. So if I want to know the value stored at X, I will call X, then X will return the corresponding value. So a variable has three properties: memory location, type, data type, and then the name used for the memory location. So for instance, for this case, X will be, our X will be the name of the memory location. The memory location will be that portion where the value is going to sit. Then the type is going to be the integer. Okay. Here they've given us some demos of how you can declare. You can use one line and declare how many integers depending on what you want, int X alone. Or you can say int V, Y, W, Y, etc. Remember, you need to first declare them before you use them. The moment you use them before declaration, the program is going to complain. Even if you're going to say, I want to use a variable called first name in your class, you need to first declare it. If you don't declare it, the program will say, I don't understand first name. So that's why these are ones that always we put at the top. In C, we studied about the local environment, the local declaration, and a global. So global, it means after the hash include, that's where the declarations are. The local, this is when you go inside the function and you put it there. Global, it means that variable is going to be accessed by anyone in the program. Local, it means it is within a certain container. Only people in that container can access it. Are we together? Cedric, I see you've unmuted. Do you have something? So we have three numerical data types, 6 of them, byte, short, int, long, float, and double. I remember these things, you already know them. The only difference with them is the memory size allocated to each type. And in it has a certain size limit. A float has a certain size limit. A long has a certain size limit. A double has a certain. But these guys are there, whatever language you're going to use. Whether using C, whether using C#, whether using what, they already know them. So we have byte, short, int, long, float, and double. Okay. In declaration of these variables, sometimes you can even initialize them, by the way. Right? Initializing it means, as you say, int or string or character first name or string first name, instead of terminating, you give it a value there and then. You say string first name is equal to your working. Then it means what you've done, you've declared and initialized. Okay? Here we have an answer, an example. Here we are declaring the variable count of an int type and also giving it a value there and then. So it means as it goes to the memory, they're going to create that space, call it count, label it count. It's going to store an integer type. Then also they feed the value there and then. So it means you've done what we call, you've declared and at the same time initialized. Alternatively, if you don't do this, you can say int count, terminate, then maybe on the next line you say count is equal to 10, which is the same thing. But when you use that approach, you're going to have so many lines of codes than having this systematic one, right? Which is just a one line. Imagine when you split these, there will be like 4 lines of codes, which can be solved by one line of code. Okay. So the system that I define precision of values, they can store in memory. You can see that the byte, the minimum and the maximum, what it can handle. So if you go beyond that, it will complain. Then you need to look for something bigger. You already studied these guys, these things. I'm not going to repeat them. And even they're here. So when assigning a value to a variable, we always use what we call the assignment operator. Assignment is the equal sign. Depends on how you're using it. That's why here you have variable equals, then expressions. Then examples are sum, which is a variable, is equal to first number plus second number. Average, which is a variable, is equal to, assuming average is going to be a float, or is going to be an integer, it will be equal to that expression. Alternatively, we can say sum is equal to 2. Also, that is okay. So an expression can be an actual value or can be a value gotten after evaluation of a certain expression. So sum is equal to, the value is going to be first number plus second number. So we use the assigning operator to assign values to a variable, which you call the equal sign. Depends on how you're using it. There are certain instances whereby you can use it when it's not meaning the assignment operations. Sometimes we might use it when you are trying to relate if things are equal, things are the same. So we shall see those instances. But here, when you want to assign a value, if you say string first name, terminate, and you want to give a value to first name, you say first name is equal to, open quotes, put the name, you go to go. Are we together? Are we together?
Yes, sir.
Yes.
Mhm. So here they're giving us some of the demo, our code versus the state of the memory. So we say int first name, which is a, second number, okay? First number is being assigned to 1234. So here the variables are allocated in a memory, which is a, first number and what. Then afterwards, you see they've been given assigned values to them. Right? Hope you can see that. First number is 234, the second number is 87. That's what is happening in the memory. This is what you have in your code, but this is what is happening in the memory. So as you're coding, just know this is how the memory is going to be responding. Another example is here. Int number is equal to 237, number is equal to. Now here, what is happening? They're going to create that variable in the memory and allocate the memory. Then they set the value of that number to 237 as the first value. However, the second line, which is number is equal to 35, is also going to rewrite what is in at that address to clear what is there and put a new value. I don't know whether what I'm explaining makes sense. So what you're going to do, you're going to override. At first, when you wrote your codes, remember these things goes in a sequence format, line by line. So it will go and create a number. Then the next line, number is equal to 237. Then the next line, number is equal to 35. The question I have, when I call number, what will be the value now? When these first three lines are
35.
exactly. So that is it. So it means what you've done, you've overridden what was there and then changed something. Okay. I think these things always happen to us when you're doing our objects. You can say, my age is this, then tomorrow you say and change it and rewrite something else. Then when I call age won't have the historical record. Age will have the most recent. So if I keep on saying number is equal to another number, so it keep on changing until there's no any other assignment happening. All right? So here what we say, C, the value overrides the previous value. That's what is happening in the memory. So as you structuring your code, be mindful of how the memory is going to react. That diagram of state of the memory is giving you a heads up of how the memory is going to behave. Okay, as you write your code, this is what is happening in the memory. Then now we have the assigning of the objects, the ones that we are dealing with now. We are writing our class. Joachim wrote a class called customer, etc. So here we shall say customer is equal to customer, which is customer. Then customer is equal to new customer. Customer is equal to new customer. Then it means we have new objects of the customer class. So what will happen in the memory?
Sorry, beg your pardon.
So here what you've done, instead of customer is now a class which you're going to use to create your own object, right? The same way you did int a, right? Then a is equal to this. Now here we are dealing with the objects, the ones that you are writing, the classes that you're writing. Now we want to create objects out of them. Because remember, the objects are the final things that we're going to deal with. The class will help us to get an object. So here we are saying customer class, which represents customer, right? Then customer, the same customer is equal to near customer. So it's creating a new instance of a class, which is going to be able, we are going to be able to manipulate and edit. Remember, a class, you cannot delete it when it's running, but you can create an instance, a duplicate of it, and then try to jog around with it, which represents the other original class. Now here, in the assigning of the objects, we have two of them. When you look at this, the state of the memory, they're saying us, okay, we have customer representing the customer class. But then after the same customer, we go ahead and create the objects which are representing the new customer record. So the variable A is going to be allocated in the memory. Then B reference to the new object assigned to the customer. Then C, another object over as a reference in the customer. So you have customer is equal to new customer. Now here you can say Ilias equals to new customer. Joachim equals to new customer. Barbara equals to new customer. Then you have like, those are the different customers we have in the system. I don't know if I'm making sense. Am I making sense?
So, sir,
Yes, please.
so in this case, we are having two objects, the two objects in one class.
Okay, it's one class that we're using to generate two objects.
Yes.
Yes.
Okay.
So it means when you have a class called sales, right? You're going to have an object of maybe a set of a pass, an object of a set of maybe an appliance, another one, an object of a set of this whatsoever. But as you read your code, look at what is happening in the memory. That's the most critical thing. Because if you don't know what is happening in the memory, then you will never know how to troubleshoot your code. Okay, understand what is happening in the memory, how things are being looked at as you write them. Maybe that one will help you to write codes that are going to not to complain or throw exceptions. Then also have this scenario. We have customer, Clemens, and then trade. So it means we have two instances. Okay, we have two variables representing the same way we say int v, comma, y, or int x, comma, y, then terminate. Now here we say Cleans is equal to new customer, then Taiwan is equal to then is referring to the other object, Cleans. So this is what is happening in the memory. The variables are going to be allocated, right, in the memory, which are of a customer class. Then after B is set B, the reference to the new object is assigned to, which is this. Now C is the reference in is assigned. So now C is pointing to this guy, that Taiwan is equal to this guy, claims, which claims is an instance of a new class, or which claims is pointing to the class, the new object that we are creating. Are we on the same page? Please ask me questions, because I'm going to tell you to go and write these codes. Now I'm telling you what is happening in the memory as we write your codes. Yes? Silence means none. Okay. Now, primitive versus reference. Primitive, I talked about the primitive. Primitive, it means they come preloaded with the language. So all numerical data are called primitive data types. I would say they are natural to the language. or they are by default. Even if you do a factory reset, you'll find the integers there. Remember, for us, we're going to be dealing with, I would say, numerical data, objects, and so many things. But remember, an object can be a composition of primitive data, strings, so many things. Because you can have an object that has a string, has an integer, has a float, has what, no one is going to restrict you. So numerical data called primitive data, already they come with the language knows them. Objects are called reference data type because the contents are addresses that refer to the memory locations where the objects are actually stored. I might ask you a question in future. What's the difference between primitive and reference? So this is what I'm expecting. You can give examples and you can give whatever definition. Just know primitive data, those are the numerical data. Numerical data, we talk about there are 6: long, short, int, float, double, etc. Objects, we will know objects. The moment you write a class and you call it to start manipulating it, it's no longer a class now. It ceases to be a class. Now you're dealing with an object. Okay. The arithmetic operators, here is a summary that are available in Java. Addition, subtraction, multiplication, division, modulus. These things, by the way, we did them. And all of you guys did them in programming. You know them. I might not even talk about them. No one doesn't, I don't believe that we have a person doesn't know past addition, minus, subtraction, multiplication, division, modulus. Even he did some examples of how they can be. The same logic you use in C, the same logic that is applicable here. Now, let's look at the arithmetic expressions. Consider this how does expression x plus 3 times y? Now, when we look at this expression following the board mass, right? How is it going to be executed or evaluated? What will come first and what will come last? Using the board mass knowledge.
Multiplication first, then addition.
Why multiplication first?
Board mass.
Board mass, we start with bracket. I'm not seeing a bracket there.
No, you just create the brackets with 3 times y. That is the bracket where I put.
Okay, so x is answer is x is added to 3 times. So ideally, we have to first get what 3 times, because when you look at the precedence rules, addition and subtraction, they are at the lower level. The other brackets and what they are the higher things. So if you write an expression that has those combinations of operators, just know how the reaction is going to happen, how the computer is going to look at that, right? So here I would say, we determine the order of evaluation by evaluation. It means converting this to get an answer, because we shall need to look for what is x, substitute to this value, and what is y, substitute this value, then you do the multiplication, do the addition. That's the evaluation. By the time you see the answer, it means that the expression has evaluated. I'll use the evaluation because I believe we are scientists. We know this. So for us to do this, we have the precedence rules. Higher precedence operator is evaluated before the lower one. However, if two operators are the same precedence, then they evaluated left to right for most operators. Assuming you have, I would say, x times 3 times y. Those guys are on the same level. They have the same precedence. So it means now the program or the compiler, the computer will look for, it will start from the left going to the right. But in this situation, it will have to first deal with the operator that has the highest precedence, right? When you come to the table, we can look at it. You see the precedence rows? You see what is high? Anything that you put in brackets is considered to be high. It has to be first dealt with first. Okay? Then we have the unary operator, Then you have the multiplication. Then you have the additive operator, which is log. Okay. So the inner operators, this is when you do plus plus, then this is when you do minus minus. The multiplication, you know them. Look at that, the additive and the subtraction one, they are at the bottom. So if you use them somewhere, yes, Priscilla.
Yeah, you've said on this precedence, for the precedence roles, the higher ones come first. Huh?
Yes,
So it means board mass does not apply.
it applies. I think
But how?
what we're trying to do, we are trying to mimic when you go to board mass, brackets are the first ones. Even here we say the bracket, the sub-expression, the brackets are the high. So it's mimicking the board mass architecture. So anything you put in a bracket, that is the thing that's going to be first be worked on.
Irrelevant of it being
Yes.
subtraction or
Yes,
division.
anything, it has to first deal with what is in a bracket.
Okay.
It will only apply that further splitting when within the bracket you have multiple operators within. Then it can also apply the same logic into the sub things inside the bracket, but the bracket is going to be first treated first. Have I
Okay,
answered you,
thank you.
Priscilla?
Yes.
Okay.
So,
Yes.
I also have a question.
Yes, Joachim.
What is the difference between the unary operator and the additive operator? Because
Okay.
the unary it's minus, plus,
Hmm.
and the additive is plus, minus. And then the same, just that.
The other side
The
is
organized.
unary minuses and then pluses. I think we did something in when you're doing loops, these control structures in programming. For I is equal to this, I is this, then I plus plus. That's a unary operator plus plus.
Okay, yes, now I get.
Okay, I minus minus. That's a unary operator. Now it ceases to be because it's no longer now doing the other normal operation of adding. It's doing something else. Are we together, Joachim?
Yes, sir.
Now, we have what we call typecasting. In programming, when you're going to do any arithmetic operation, the principle is that all the operands have to be of the same type. If you're adding an integer plus an integer, it makes sense because the operator is going to check. Actually, the computer is going to check. Are these guys the same? If they're not the same, it will try to do some automatic conversion, or it will complain if it finds a challenge. If X is a float and Y is an int, what will be the data type of the following expression? Right? The answer will be a float. Why will the answer be a float? Expression, we call it, is a mixed one, a mixed expression. Why? Because it has variables that have different data types. One is an integer, the other one is a float. But when you do this, the compiler won't complain, the compiler will complain. It will give you the answer, and the answer will be converted to a float. So why would the answer be converted to a float? So they are converted to a float because we have what we call the promotion rows. Promotion rows ensure the data type of expression will be the same as the data type of the operand whose type has the highest precision. When we look at the integer and the float is more bigger than the integer. So there is no way we're going to convert a float to an integer, right, as our result, just because the float or maybe whatsoever. But what we can do, it will deal with that, but then it will convert the answer to a float because it's very easy for it to convert a smaller guy or a lower guy into a bigger guy or a higher guy. So that's the promotion one. Why you're getting a float after adding an integer with a float is because of the promotion rules. When you look at the float data type is more bigger. I would say it has a high, it's more dominant than an integer. So that's why even the results are going to be dictated. So the program will allow you to do this computation, but just know when I add a float with an integer, the result will be a float, whether I want or not. So then you can deal with it in the right way, you know. If you want maybe the result to be an integer, you have to do some conversion yourself. But by default, this is what the language will do for you. Are you on the same page? We've heard about the precedence rows. We've now seen the promotion rows. Precedence, we talked about the body mass element, right? Operators that have the highest, I would say, ranking as far as the precedence rules are concerned are evaluated first. Now the promotion, now we go to the data type. We have some data types that have some bit of dominance. So it means that if you use it alongside with the other one, which is called a mixed expression, it's going to override the other smaller one, then the result will be in the bigger one. Questions? By the way, I like it when people asking me questions. Otherwise, I feel challenged. If people are quiet, it's only Joaquin, Clever, and Priscilla. The rest I don't, you know. And I'm awarding marks for asking questions. Yes? Yes, please. Questions?
So we have understood.
Okay, so this type of conversion or this kind of approach is, we call it typecasting. For an operation to happen, any arithmetical operation to happen, those guys have to be the same data type. That's the policy, oh, that's the law. So that's why it's being converted to using the promotional rules. However, you can also override and dictate and say, no, change the float to an integer because my result is supposed to be an integer. So that process is called the typecasting. There is no way you can add a float with an integer, and then you expect, because the question is, how do you want the answer to be? It's the same as saying I'm adding a boy plus a girl, then what do you expect to get? You're confusing the computer. So the same principle you apply in life, the same principle you apply here. The expression is going to be accepted, but now we have rules that are going to work silent in the background. They will change automatically, right? However, we can change it ourselves. Instead of relying on the promotion rules, we can make this by dictating and telling it, no, the result should be of this type, right? For instance, you see you have the data type, which you put in bracket, then expression. Then here I'm telling you the first example, whatever you're going to get x divided by 3, it should be a float. So x should be a float, then divided by. Then also we have this, that whatever is going to come out of the bracket, convert to an integer. So this is explicit typecasting. You define, you tell it. So the same thing when you're recording data on your object from the keyboard and someone enters a number, but you record it as a string. So what you can tell it, convert that input, tell it that, okay, much as people are recording a string, but for me, I want it as an integer. So it won't disturb people from entering whatever they enter, but on the runtime, it will be converted to an integer. For you, will be dealing with an integer. Sometimes we get the age as string, yet you need to do some computations with them. So this is when you say, you cast it and say, okay, whatever you're going to get out of that, I need it in this type. Okay? Then you also have the implicit one. Look at the following expression. Now x is equal to 3 plus. So the result of 3 plus 5 is an integer. When look at them, 3 and 5, those are integers. However, just because we say that the variable x is double, right? So it means now the value of x is going to be promoted to a double type. Okay, so the result, which is 8, is going to be promoted to 8.0, represent the double. Okay, is that okay? We've seen 3 ways of doing casting. There is the implicity, there is the explicity, there is also the use of promotion rules. You can change the value in whatever type you want. Are we together? Yeah, I'll ask you questions. Keep quiet.
Yes.
Sorry? And here they're telling us that, okay, much as we have a promotion, but we don't have the demotion. Okay, demotion is like changing the bigger guy to a smaller guy. So people, I know people are going to say, okay, you have promotion, then demotion. Yes, clever.
You said that we can go on to override what the program will print out. How do we do that?
Explicit one. When you say, okay, consider this example. 3 and 5, those are integers. When you add them, the result is going to be an integer, right? But we are overriding this to convert it to a double. We don't want an integer for our own reasons. That's why we're saying double x is equal to the result of 3 plus 5. But from the back of our mind, we know that a 3 and a 5 are integers. And if they evaluate and they sum up, we shall get an 8. But just because we don't want an integer of that nature, we are now overriding that or trying to change the type by doing it with the declaration of a variable that's going to hold that summation, calling it a double. So it means now, as the 8 is being computed, before it's assigned to x, it has to be converted to a float double, which is 8.0. I don't know if I've answered you clearly.
Yes.
But it's
Sir.
not, yes, Joachim.
Why do we change the, okay, yes, we're changing the value of x to a double.
Yeah.
I thought, since you said previously that when we are converting, we change the smaller value to the bigger one.
Yes.
So in this case, I thought that we shall change the 3 to 3.0 plus 5, because we are changing, now we have changed the smaller one, which is 3, plus the 5, converting into a double.
Okay. Joachim, when I say that you're changing the smaller one to smaller one to the bigger one, we are not changing the numbers, the values. We are changing the data type. Right? We are dealing with data type. When you look at 3 and the 5,
Yeah, okay.
the data type is an integer. And an integer is smaller than a double. We are not changing the actual numbers, but we are changing the data type. That's what we are dealing with. Joachim, have I answered it?
Yes.
Okay. Now, we have some constants. You realize that you're going to write your programs there, and you need values that are going to remain the same throughout. For instance, if you're writing a method that's going to compute, for instance, you're going to write an OP program that records or tracks the employee information. That's going to compute the payroll, the what, etc. Now, with that, when you're computing your net pay, we have figures that are going to change throughout. Like, what's the rate, what's the percentage for paying? What's the percentage for NSSF? That figure is going to be constant. It has been there for generations. There's no, it's going to change. Okay? So that's when we can apply the constants in our program and make use of them. Okay? It means that value is not going to change. Whether you want or not, whatever what is going to say, the NSSF contribution will never change. It's always 5%. when you convert that to what the machine can understand, which is 0.05. So when you're writing an HR, a payroll function to generate the pay of a person, that figure has to be there, it shouldn't change. All right. So this is when you apply the constants. When you're going to compute the temperature, we know there are certain figures that are constant. You set them there. So here we say we can change the value of a variable. If you want the value to remain the same, we use. Remember, in the first slides, I told you declared an integer, and then you said number, int number, then number is equal to 237. Then down we said number is equal to 35. So it means we have provision of changing the values of those integers or those variables. It is allowed and it is okay. However, if you don't want to do that kind of work, you want the figure to be there and there, okay? This is when you use the likes of constants, okay? For instance, if you want to use the constants, the constant, we have a keyword. A keyword is the reserved word that you cannot use as a variable. Those are some of the rules of naming variables. You cannot use a keyword like int to represent your variable, because already the program knows that int represents an integer. Now here, if you want to declare a constant, you need to use the word final. Okay? Final double PI. It means PI will never change and it's of double type. Okay? Final int, whatever you want to declare, or final int NSSF for a contribution or percentage, or final double pay contribution or pay whatever. Depends on, because when you're writing your programs, you know things which are going to be constant, things which are going to change, so you set everything. So final is the word you're going to use in Java to declare a constant. Also have these constants, which are also called the named one. They are part of the language, month in a year, Faraday day constant. These ones are okay, we need to go and check on them. And then also you have what we call the lethal constants, the numbers. So when you say final, okay, then int, month in year, then 12. It means final is the keyword we are going to use. Month in year is the name of that constant, okay? Then 12 is the value of that constant. The same way you say int x is equal to 2. It's the same way you're following. Int is the data type, okay? Then x is a variable name. For instance, x here is the named constant. Then 2 is the value, which is the literal constant. The only difference here is, instead of saying int month in year is equal to 12, we put the word final to tell it that it's a constant. But it's the same approach you use for declaring variables. Are we together? Are we together, good people?
Yes. Excuse me, sir.
Yes, Samuel.
Like, for example, for us in C++, we used to use const instead of final. I've understood that.
Yeah, actually it's the same. Remember, these languages differ in syntax, but they all mean the same. So when you come to C#, you might not find the word final, you might find the word constant. When you go to C# or C++, they will have something, but at least these things are there. Java uses the word final to represent a constant. Other languages, it doesn't mean that final applies everywhere in all languages. Final is for Java. Other languages might be using different terms. Have I answered you, Samuel? Samuel?
Excuse me, sir.
Yes, Angela.
Yes, sir.
Have I answered you, Samuel?
Yeah, you've answered me.
Okay. Yes, Angela.
Why is it here on the last one where there is final short? You've put here the word final, and also here you've put the word constant, and as if they mean the same.
Oh. Okay, final is the word we use to declare a constant, right? But much as we're declaring a constant, it has to be the data type. So double int short, it's a data type. Then pi, math, in year, Faraday constant, these are just names of that constant. The same way you can say string first name. So the name, leave the naming, you can name it the way you want to name it, but that's the name that's going to be stored in the memory, and the value will be attached on that name. So you can name it the way you want to name it, depending on how you interpret your things. Angela, have I answered you?
Yes.
Yeah, leave the constant word alone. It was just a naming. This is how the author of the book decided to name it. But for you can name it anything. Mine, I can say, find a double NSSF. Then I say 0.005. Then next I say, final double payee equals to, or I can say, final double payee constant equals to, it is upon you to do whatever you want. Now,
Then, sir,
yes,
excuse
please.
me.
Yes, please.
As we are declaring those variables, do we do them after the main function or before the main function?
Okay, when you look at most of these things, but they have to be inside the main. Most of these, they have to be inside the main. Because remember, whatever you're going to do is inside that main, right? If you want these declarations to be maybe globally accessible, some of them, they can put them above the main one, or some even might go within a certain function and place them there. That's why you said, okay, there is local and global declaration. So at every point where I declare those variables, it has to be informed by, how do I want to access this variable? Do I want to access them inside the main or outside even the main? If outside the main, where should I place them? Because the moment you lock them somewhere, yeah, they are locked. It means no one can access them. Only people inside that gate can access. So look at the structure of the program. We have a section where I do the importations. Import java.utils, etc. Most of the lines, when you follow back the C programs we did and C++, after doing those importations of the preprocessor directives, we used to do the declarations from that point to make them global, right? They also have impacts on your program when you make them global, but you can out once say, okay, if I make them global, will I benefit? Okay, is it worth it or not? If it's not worth it, then you make them lockable in a certain area whereby you're only using them at that particular area. Or you make them global that anywhere you are, you can access them. I think you did those declarations in your C++ programs, whereby you did hash include this. Then after those importations, then you did int A, int Y, then you define your main method and you write then you can call X, you declare the app, it's now access-based global. Or you go to a specific method, you put them there. It means now it's local. Angela, that answered it.
Yes, sir.
But I would recommend the class you had with Mr. Kasozi to revisit that code and try to shift those variables in different locations and try to access them and see. As they keep on complaining, you are learning and you're understanding how they work and where should I press them.
So what do you mean by shifting them to different locations?
Yeah, okay. At first, okay, if they are at the global space, you can now maybe put them under the main and see what is happening. Right? If I go outside the main, let's say if I declare another function outside the main, can I access them? Or if I put another function within the main, which is called something, then I put a variable inside that function. Because remember, on our classes, we have attributes, the class name attributes, and then the methods. You have the get and set. So you can decide and say, okay, let me put some variables under the get and see if I can access them outside the function, outside the method. Will they be accessible? those are some of the changes. Those are some of the steps you need to do and see and understand how the program looks at what we are writing. Joachim, have I answered you?
Yes.
Mr. Kasols told me that you did methods on the program that you did last time.
Yes, we did.
Yeah, so you can declare some variables in those methods and try to see if you can access them within the other methods. Now, displaying numbers, the numerical values. I've talked about this. We already know this. We've seen this in C. Displaying is we use system.out.print. You get. So when you're displaying a variable, you see how the line is. When displaying a string, you see how the format is. When displaying a constant, you see how it is. Are we together? So depending on what you want to display, you use those lines according, depending on what you want to display. So if you're displaying a variable, the first line applies. If you're displaying a string, the second line applies. If you're displaying a constant, the third line applies.
Excuse me, sir.
Yes, Madam Angela. Yes, Angela. Angela, unmute. I'm here.
Yeah, sorry. I was like, when you're displaying a constant, you put the number or the integer in the bracket.
Yeah, why it's called a constant is okay, you've just had coded the number there. But a variable can be a number that's going to be changing every now and then. That's why it's you are calling the variable name. But a constant can be a random number you just put there, and there. That it is what it is. But if the number is going to be dynamic, then we are advised to use the variable approach. Yes, Angela?
Okay. It's
Okay.
okay.
Now, we have this operator overloaded plus. That operator is very funny. Depends on what context are you using it. The plus operator can do so many things. Right? It can add. However, it cannot only add, it can also do some other things depending on what context. That's why we call it overloaded operator. This one operator that can do so many things. When you give it, that's why you say that can mean two different operations depending on the context. So in say var plus var is an addition if both are numbers. Okay? However, if one of them is a string, then it doesn't do the addition. It will do the concatenation. Did we do by the concatenation in C? People did C with me. I think Joachim did some concatenation. Yeah, but we add strings together.
Yes.
So the plus operator is called the overloaded operator. It can do two things depending on what context. So if you give it the operands, the expression that has both operands, this side which are numbers, it will do the addition. But if one operation is a string and the other one is a number, it will do the concatenation. So it will convert everything to a string and then says whatever it is. Yes, Angela.
Me?
Yes, Angela.
No, sir.
You've unmuted. It looks like you wrote some.
Sorry.
Right? So if the number, the operators, where the plus operator is, the operands, they are numbers, the program will interpret as that as a summation and it will do the addition. If it senses that part of the operands, one is a string, right? Then it will do the concatenation. We've studied about the promotion, studied about the certain rules. You have the precedence and then the promotion. So when we have a number and a string, what rule is being applied here? Is it the precedence rule or the promotion rule. When the plus operator is in between a number and a string, what rule is being applied? Can someone tell me?
Beg your pardon of the question.
For instance, val1 is a number plus val2, which is a string. We said that what the operator will do, it will just do a concatenation. What rule is being applied there? Yes? Hey, Joachim, you've also forgotten the rule. Angela, what rule is there? When you look at the result, it's going to convert to a string. Oh, Samuel, that is not encapsulation. The rules we've talked about today, one is promotion, another one is what? The precedence. When you look at that, the rule that the operator will apply is called a promotion. It's going to change the other guys because when you look at the string is a little bit more bigger. It will all dominate everything, then it will do the concatenation. Then the integer will be converted to a string so that they can be mashed together. Okay. Sorry, who? You said that you didn't understand it?
I didn't hear you very well.
Oh, I said that when
I
you,
stopped hearing you.
sorry, I think my machine just went off. Can you hear me now? Joaquin, Angela, can you hear me?
Yes, sir.
Okay. I was saying that when you look at the way the operator plus is overloaded is if the expression has both numbers on the right and the left side, it will do the addition. But if one is a number and another is a string, it will do the concatenation. So the rule is going to apply the string, it's going to be the promotion rule, because it's going to convert the integer, whatever type, to the string side, the string format, then it does the what? The concatenation. Concatenation, it means I'm getting a string plus a string to form a one. Let's say if in your methods that you're going to write in your classes, you're getting the first name, you're getting a second name, but we want a method that I will do is return the full name from that object, which is going to do first name plus last name. That is string concatenation. So you're going to use the plus operator within the strings to do the concatenation. However, here we say that if the operands, one is an integer and the other one is a string, it will do the concatenation. It won't do the addition. Yes? I'm going to this network.